All right, everybody, let's look at our last example. So we've already started this, but we're going to start again. So example 4, we're going to put arrows on both ends, okay? The reason why we're going to do that is because we want to imply that this graph goes continuously in both directions. So the domain is going to be negative infinity to infinity, or all real numbers. That simply means that the graph continues to go to the left forever and to the right forever, even if we can't see it. The range, now this one gets a little tricky. So if you remember, an exponential approaches an imaginary number or an imaginary line. So it's approaching the x-axis, but remember it's never going to hit it. So actually, let's go ahead and add something, and let's add that we have an asymptote of y equals 0. That simply means that the x-axis is the point that the graph approaches but never hits it. So the range then is we're going to say it's from 0 to infinity. Now, why don't we use the hard brackets for 0 or infinity? Well, if we use the hard brackets for 0, that would imply that it reaches 0 and it doesn't. And remember, we can't reach infinity. So the lowest it goes is 0, not including it, and the highest it goes is to infinity. Another way that you could write this is y is greater than 0. That would be an inequality that would say the same thing. X-intercept. Again, it doesn't have one because it doesn't ever hit the x-axis. Y-intercept for this graph crosses at 0, 1. Now, real quick, does this graph have a maximum or a minimum? No. Since it never reaches 0 but gets closer and closer and closer, it has no minimum. And then it goes up to infinity, and because you can't reach it, we say that there is no maximum. All right, so in behavior. So first, let's write it in words. So we're going to say, as x goes to the left, okay, what happens to the y values? They're going to get larger and larger and larger. All right, what about as x goes to the right? Well, the y values are going to get smaller, but they're only going to be approaching 0. All right, so let's write our formal notation. So we're going to say as x gets smaller, so that's going to be going to negative infinity. So let's get our arrow. And remember, our arrow always goes to the right. That means approaches. And then we want to say, ooh, that does not look like an infinity. Oh, it's a smart computer, though. So we're going to say, as x approaches negative infinity, what does y do? Well, it gets larger and larger and larger, so it's going to approach, and some people use that to do the arrow, and that's fine. It's going to approach infinity. That just means that it's going to get larger and larger and larger. So as you go to the left, y gets bigger. All right, well, what about as you go to the right? So as x approaches positive infinity, just means x is getting larger and larger and larger. What happens to y? Well, y is going and approaching 0. Remember, it's not going to hit it, but that's where it's going to be. All right, so make sure you take careful notes. You're going to use these to help you as we go forward, and good luck.